Nice. Well, how was your day otherwise? Busy at the clinic?
Yeah, so we're with the holiday and all that, we're down a clinician, so that means or two. So I gotta hop in and do the things.
Yeah, I hear you. Well, I say half the time I'm totally used to that being like, oh, sorry, I can't make the call anymore because in the middle of a clinic or something. But yeah, I'm glad we had a chance to just sit down and have a chat and talk about what we're working on and stuff. I was thinking it'd be cool to just sit back and flow through Nomad Sculpt for the first time and
Yeah.
see it through start to finish, and then we can pick up on your side and some of the cool stuff you're doing. Because yeah, I've really enjoyed the idea of your socket generator. So for anyone who doesn't know, what when is this coming out and what does it do and how is it serving the OMP community and advanced 3D?
So it's out,
Mm-hmm.
um, but you do have to sign up on our website, and we have to give you permission to use it. We're still trying to figure out what the best way to do, because I think we've had this discussion before. Developing software and websites and all that stuff is not free as much
Mm-hmm.
as we'd love it to be, and so we've got to figure out a way to take care of that. But I think the time savings and the consistency is going to be a big deal for this sort of process.
Yeah. Yeah, and consistency is key. And my manual tools are great for getting people into the game, but then yeah, you do come up against that as one of your main pain points when you're doing custom, right? Is how do you stay consistent? How do you keep your rules the same? How do you keep your process the same? How do you keep your timing the same? So I think your workflow is really going to help people. Have you had a chance to play with Nomad Sculpt at all?
So I've played with it some, but yeah, I'm kind of curious to see it go all the way through, because it's probably like any other software. There's buttons and places that you wouldn't expect or you
Mm-hmm.
just don't know. And then, yeah, there's just the overall language is a little bit different. But from what I've seen, especially with what you've done with Jeremy from Dankmeyer and that sort of thing, super impressive, really.
Mm-hmm. No, and I was blown away myself. I just, I'm not in. I should be endorsing them and getting a sponsorship, but that'll probably come later. Yeah, it's a complete replacement for ZBrush, and it's really light and easy and affordable and cheap. So I have this random scan here, and so I'm hoping you can help me drive, and you can help me with the clinical side because I'm always disclaiming. So you can give me your trim line feedback as we get to that step.
Okay, let's do it.
Let's do it. So looking at this scan, it's a high resolution scan. If I turn on my grid, I can see it's not aligned, and I can see my wireframe. It's high density. I would imagine this was done not on an iPhone or something of that sort. So the first thing I always do with a scan is I got to align it to the world space. And today we're aligning to something special. We're actually aligning to your Bulldog, which your program accepts. So I actually brought that in so we can see it here. And so I have to align my scan to the Bulldog. And I'm going to be doing that after I clean up some of the stuff that's going to get in the way. So all this stuff. So thankfully, they have a really cool, quick tool called Trim. Trim just lets you take an Apple Pencil and just drag out what you don't want in the scan, and it'll... Oh, nothing to trim. Wait a minute. Am I in the right... I'm not in the right one. There we go. Select the correct body to work on in our scene tree. Try that again. Let's trim away the top edge of this. It's going to heal and create a watertight solid, which is great. And that's step one is done. Let's try moving this now. So there's a gizmo tool in our toolbox. And this gizmo tool, I need to align it to your Bulldog. And so if I keep it on align, it'll stay world space aligned, which is great. I'm going to try and just sort of generally line this up, looking at it from the side. So bringing it about, let's say there. Looking at it from this side, we'll bring it over. Looking at it from the left, bring it up. And now I'm wondering if benchtop alignment is necessary at this stage. but we can do that at any point in the stages, right? I always sort of say that even in Fusion, at the very end, you can still adjust your alignment, but just generally aligning to the world space, I think, is a good practice overall. So how far off do you like your bulldogs from the distal end?
So, well, and if you look at the bulldog, that does have there's an A and a P. Okay, yep,
There we go.
yep. So that's to help line up anterior posterior.
Okay.
Um,
So I think I got that correct.
so
no, posterior is back. You're right. Let's align that. So we'll look at it from the back side. Try and get
and
that right.
yeah, and so that's one of the things that and it's just probably me, but I prefer aligning from the backside first, so it allows me to take a look at the hamstrings and kind of line of progression, and then I flip around to the anterior to get my rotation, and then I'll flip medial lateral for flexion extension.
Okay.
So
this kind of can you see the hamstrings?
So, well, you can see the flare, right? So, but yeah, you can. Yeah, it's not too bad.
Not too bad. Looking at it from the side.
I like that.
Yeah, you like that? Okay. Front.
And so not. So look at it from the kind of the distal end. Kind of looking up. There you go. So that allows you to take a look at the distal end of the tibia, and also how the patella is lined up to that. And so I think that's fine.
Okay, great. Good to know.
And so then as far as your height goes, so you typically there's an umbrella that has a little kind of button on the bottom of it. So when you're fabricating these traditionally, you typically will take a Sureform and cut it off flat until the bulldog will sit flat on the model. So what I do here, because we do some little tricks in our automation, is I will actually bring it down and let the distal end. So if you bring it down and let the distal end inside of take it up just a little bit, down just a hair, and I think you're going to be there.
Okay, so let's go down 1 millimeter. Oh, that's not 1 millimeter. There we go.
Yeah.
How about that?
And we probably need to move it just a little bit further forward overall. Yeah, something like that. And more often than not, you're going to have an umbrella, so you're not going to run into this issue. So you can see posterior, you've got the that extra gap there, and in this case, that's fine. So we can continue moving on. We'll take care of that in the automation side of things.
Okay, cool, nice. So we've aligned the world space, we've cleaned up the scan, and we got to maybe just clean up the extra bits in here. I do have a mirror on. I hate that. That's one weird thing about Nomad. They always turn on the mirrors. Let's turn on X-ray. I'm going to quickly smooth this out, holding down Shift on my little keyboard for my iPad, which is amazing. You can run this like a CAD package. Hey, like you can run a mouse and you have all your hotkeys if you want to. And a lot of them are sort of standard ZBrush convention even, which is kind of funny. There's a flatten brush, which I'm going to use here just to help with some of these things that don't smooth away.
Do they have anything like a D feature or anything like that, where it takes out a big, like you can highlight and takes out a big chunk?
I don't think so. I mean, we can mask and then smooth and then flatten and smooth and even remesh. Yeah, I don't think the D feature is specific, but yeah, I know what you mean. Some CAD packages have that. A lot of this other stuff, like these small seams, aren't really going to affect my outcomes for quad meshing. All of that tends to just fall away when we reduce the resolution. Right now we're working in 60,000 points, and I'm aiming for a quad mesh of about 1,200. So it's going to be, very, very small compared to what we have. But I would say that looks okay.
Yep.
Sweet. So now we're going to draw trim lines. Trim lines are best done with groups because we can control our quad meshing with groups, and they have a face groups tool. which is really awesome. You can do things like draw and also lasso rectangles, ellipses to make these groups. And you can choose your colors for groups too. So we have colors right now. There's a few that have been healed, and I kind of want all of these to be the same color starting off. So I'm going to cover that. Make sure there's nothing down here that's a different color. But let's choose a new color for our trim line. All right. So this is the exciting part, the part that I never get right. So where do you start with your trim lines when you first start drawing? You start in the front?
Yeah. So I will start kind of right proximal to the patella. Yep.
Okay.
Something like that.
Something like that. Coming up.
Mm-hmm.
Coming up.
Yep.
Looking at from the side. Hopefully I have enough of a scan. I think I have enough scan.
Yeah, you can be under that crease where it kind of flares out.
Okay. And so when you do with this height to this height, what's the rule there? Is it generally lower?
So now you're wanting to open up a can, don't you?
Oh no! All right,
so,
just tell me the right answer then.
Well, so like in your typical school answer is like the proximal aspect of the posterior is a quarter to a half inch under the MTP, which would be distal patella. I actually will go higher, so I will start at the level of MTP, and then I'll drop if needed. And here's the reason why is if you play your cards right, and if you're up high enough, you can be between the hamstrings channel. And I don't know if you've ever seen those people that the patients that bend their leg back and they've got this massive gap at the front of their socket.
Yeah.
That's because the posterior wall's too low. So what happens is they lever out of the posterior wall, and then there's a massive space. So that same thing happens while they're walking as well. So the idea is you want to be as high posteriorly as you can, but that requires an eye and a care to fit.
Okay.
So that's where you start, and then we always say you negotiate from there.
All right, gotcha. So if I came in about this level,
yeah, you should be good there.
All right, so I'll go over here, and that's a little too far in. I'm assuming I should come out a little more.
Yeah,
something like that. I've seen enough sockets, but haven't clinically advised enough sockets. So something like that, nice and quick, nice and dirty, and all of this can be cleaned up at any point when we do the quad meshing. So I'm going to go across. There's a little dip here, come up. Nope. And then back over and around. How's that?
Yeah.
All right. First one is done. And now we can talk about modifications. Zoning out our modifications. So everyone's got a different answer. I'm sure you have your own. I try and follow textbook stuff just to stay neutral, but do you have a particular style we want to do today?
Well, it would be hard to do it with this model, but so for my preference and the people that I know that have done it is it used to be called the RCR method, but now it's called the Stable Flex method from Coyote Design. So it's a high tension fiberglass mold that's taken, and so then you don't end up having to do much of a reduction at all. And then their premise, and one that I believe in too, is total contact, unequal pressure.
Oh.
And so, in that, that's important is when you have a pin locking mechanism, you can't be tight in 2 dimensions. If you're tight in 2 dimensions, patients have trouble getting down into their socket. Most people, so I prefer to be tighter in the ML direction, and I let the AP direction go. And the main reason is the vascular bundle is behind the behind the knee. And so if you push in on the vascular bundle on the AP, you're actually cutting off blood supply and circulation back up to the leg, which is why so many patients will decrease in volume throughout the day. And so, yeah, so probably more than what you wanted to know, but technically not good for business because, you know, people want to do a lot of replacement sockets. But it is, in my opinion, the right way to do it.
Yeah.
So,
all right. So we need to zone our medial and lateral areas to be reduced. And then are you offloading the distal end at all, or
so when you're casting with a high tension fiberglass cast, you actually don't have to offload because you automatically get a natural elongation that happens during that. So that's a good point, though. Like when you go into the digital space, and that's what I appreciate about, I don't know if you've watched the Ampero videos on how they actually wrap. They use they do a high tension saran wrap, and then they scan through that.
Yeah.
Which is, it's pretty cool. It's the same concept. And then when you do your reduction, you just leave the top open and the bottom open, and that way you get a reduction circumferentially rather than in length.
Okay, awesome. Very cool. So to replicate that, then, am I going to be doing like a band of saran wrap across the middle here to reduce it?
So I would say for this one, it's a pretty prominent distal tibia. So you'll want to add material to that distal tibia.
Mm-hmm. Okay. All right, we'll start there. So into this area here, change to the correct color, and find the right. I'll pick. Oh, try that. There we go. So in this area, if I remember correctly, it's sort of like a triangle shape, right?
Yep.
Yeah, so something like that.
And probably not as wide on those corners.
Okay.
Yep.
How's that?
Yeah.
Right.
That's yeah. And then that buildup doesn't necessarily go just out. It actually goes out and down.
Out and down. Yeah, so almost like a flattening. Or maybe I might try and use the scaling tool to try that. I have seen that. All right, so something like that for that first one. Mm-hmm. And then the medial lateral group, would that be a band and then with a one-dimensional scale? Or would we actually just draw out a section we would try and flatten and bring in a bit?
Yeah, so well, there's actually two. So you'd have two sections that you would kind of blend together. So you'd have your first that's not going to be touching the bone. So I probably what I would start is like do the ones that are going to be pretibial. So on the medial side, you'll have one zone that's going to be the exact same as the lateral side, so the interosseous space.
Okay. And would that be like, if I drew a shape, where is that on this?
So that is medial. So that would be loading the medial flare.
Okay.
So if you take that on the right side of the screen and you take that line out and move it back
here,
a little bit further forward. There we go. Yep. Okay. Yeah, something like that.
Okay.
And then and then right next to that, you're going to have a different color.
Okay.
Same length.
On the posterior or anterior side?
No, right next to your pink. So right to the right of the pink.
Okay.
So that's like if you reach down to your shin bone and you feel the flat side on the bottom of your
yeah.
So that's what you're trying to load now.
Okay.
So and right where the orange collides with the pink is where the edge of that bone is.
Gotcha. Good to know. So and then you were saying something similar on the other side.
Yep.
Okay, same thing, two colors. Whoops. 1, 2.
So just the orange
Oh, just
on
the
that
orange.
side.
Okay,
Yep.
gotcha.
Or the pink. Whatever side that the orange. Yep.
Okay. Okay, so nope, don't do that. Let's try again.
A little bit further
Central
to the right.
to the right.
Yeah.
Okay.
So if you feel like your shin bone and then you feel that soft spot after your shin bone,
Yeah.
that's where you're going. Yeah,
Okay.
something in there.
All right. Sweet. All right. Well, that's definitely enough zones to move forward. Is there any others that you wanted to include?
That's it.
Okay, cool. To do a flare for the wings, I might try and just make this group a little thicker so we can call upon it later. Just as a might be the only thing I want to do. Cool. All right, so we've got our zones now. Face group tool has an awesome relax tool. This is one thing that ZBrush doesn't have, or if it does, it's like buried in a menu set that I can't find. But yeah, you can just like scrub out all of your groups to make them super smooth, which is like even in Mesh Mixer, that's something that you have. So now that we have that, we can modify using that gizmo tool, turning on face groups so I can see them. And all right, so first one, let's do the distal tip. So if I mask, I have to mask to a group. Can I turn on face groups? There we go. I'm just going to blur that so we get a nice blurred line. We can invert that mask, and now we have that to modify. I can move this mask with the gizmo tool, and if we want to move it to world space, we can, or we can actually align to normal of the surface on tap. So if I turn off the line, there we go. So I can actually choose that direction to move, something like that. So if we're doing a reduction and like going down, I think it actually might make sense to actually just stay aligned. If I do something like that. And so you were saying it kind of like goes down a bit, and it might even, if I try to use that one-dimensional scale, right, it's like coming down and flattening
There you
a
go.
bit.
Yeah. That's pretty slick.
Yeah. And so modifications too, the best part about this is that we can double tap any of these handles to give it a reading or like a measurement. So if I go 1 millimeter, that is not 1 millimeter. I wonder, oh, it must be in inches or something. So let's go down. Like that. And then looking at it from the front, you might do a one-dimensional. Would you go in at all, or would you want to kind of keep that width?
Yeah, I would keep the width. Yeah.
Okay. Something like that. Cool. All right, so let's call that one done. If I now go to masking, we can clear the mask, and we can smooth all that out. And that will smooth out with quad meshing too. Let's try again with this one. So we'll blur, invert, select our gizmo tool. We're now moving to world space. So when you reduce this, would this be a flattening or would this be an actual translation? I have success with flattening. Up to you.
Oh yeah, let me see the yeah. I think that looks good.
Yeah.
Yeah.
Just a little bit, right? It's just a little bit.
Mm-hmm.
Okay, so flattening, one-dimensional, awesome. So we'll clear our mask, go to the next group. This one was a reload, right? We're going to go in.
Yep.
Okay, so invert. We're going to move. This one probably does need to be aligned to the normal of the surface. So if we want to move in from here, it'll just be sort of a drop in.
Yeah.
All right. And this one as well, reload.
Yep.
Line on tap. And let's bring that in a little bit. So 2-3 millimeters. Oops. Oh. Mask, clear. And that looks to be, yeah, I think that's it. What do you think?
I think it's fine. I think you get the general idea for sure.
Idea, yeah. Demoing the tools. One One last thing I forgot to do is we got to separate out the top of our, separate out these colors. One more, and I double tap this. Nope. New color. Auto tap, auto tap. Now I can select that and delete it. So we're all ready. I think we're ready now for the quad meshing side. So we can, I'm going to go hide by groups. I'm going to hide that top and delete it. So now we have the socket. The socket has been modified. We are now ready to go use the quad remesher. So the quad remesher is a plugin from Exoside. About $20 in-app purchase one time, but it has everything you need. I go down to about 2,000 faces, even 1,500 faces if I can, and no symmetry. Let's try, see what happens. So if you do it like this, you can actually have your quad meshes follow the groups of your modifications. Whoops, that was not right. Which does allow you to sort of continue on, and if it looks muddy, which is kind of what happened here, remeshing a quad mesh is usually the best thing to do. It just sort of gets rid of it. There we go. And if you're at all worried about the relaxing of the shape, let's go back once or twice, even thrice. So before we go forward, we could go to our scene tree here and just clone this and work on a clone. So we have the original in case we need to confirm or double check. Hide the duplicate, work on the clone. Let's go quad remesh one more time. Remesh that. Remesh again. There we go. And so that, as long as there's no knots, and you have no knots along the trim line edge, that's really important for me anyway. So that as long as it's like a nice grid of squares, that looks pretty good. And even if it's a little tessellated, we now have the ability to bring back resolution to our level, or desired level at any point. You can work in low or high resolution. So this would be an example of like a high-res version, but we actually can scrub between them for workflows at any time, which is great for large macro edits. So for example, that last modification I said, where if we wanted to move the wings and bring them in. So remind me what the official term for that is.
ML, yeah, the ML or
Gotcha.
supercondular.
Yeah, so let's mask by group. Let's select the group. Let's invert or blur and invert. So now that we have this in place, if I were to do this with really high density meshes, you would get a harsh line, but with this low density mesh, we can do that gradual modification and then just bring back the resolution after. So changing the pivot, let's go to center of the mask. There we go. Now that it's in center, we can one-dimensionally scale this just slightly in to bring it in. How does that feel?
Yeah, it's fine.
Sweet. Let's clear the mask. Oh, clear the mask. Awesome. So there is a modified socket. Are we still in a good spot for your Bulldog?
Yeah, so I would say we probably need to clean up that distal, like smooth, like overall smooth. So I don't know how you do that, but the
distal end group.
Yeah.
Just like smooth it out.
Yeah.
And we'll bring back one level of resolution. Now, if you don't, it is much easier on quad meshing to manage your quads if we do a version that's based off of what I used to teach, where you would actually just draw out bands and control the UVs that way, because right now it sort of flows and wraps right around these shapes, and that can give you some weird intersections. But do you feel like this mesh will give you any issues on your side?
Yeah, no, I think that should be fine.
Okay, great. All right, so we're aligned. We're ready to export. We're smooth. Anything else before we exit out of Nomad? That wasn't too bad. Hey, how long was that? That was like 20 minutes.
And we talked, so there you go.
All right, so if that's the case, I'm going to export this. So let's save as new. This is going to be BK socket test. Awesome. Now, how we have to go to export though. So we go to STL,
Yep, STL is the best.
visible, or just selected. Let's do selected, and let's export the STL. I'm going to now save this to drive. Going to the right drive, and just my drive. Let's save here. Upload. All right. Perfect. So that's in a nutshell the Nomad Sculpt workflow. How did that feel?
That's very cool. I mean,
Right.
I like the zones. I like the being able to do that. You know, it would be as far. What are your options as far as measurement stuff in Sculpt?
It's limited. It's only direction, like point to point measuring right now. That's the one thing it doesn't do very well. Cool. Yeah, and especially circumferences. Like I don't know. Like CAD packages don't do circumference. Fusion 360 or SolidWorks, like it's just not something I've seen that any of them do well.
Interesting.
Yeah, that's the one thing ONP software has right now over traditional stuff is being able to measure with that.
Yeah.
Okay, so.
But I would say the beauty of all that is that like you have techniques such as like the Ampero technique, or you've got techniques such as the RCR, the StableFlex, or you even to the point of the Symphony Aqua. Like you already know the dimension, and it's been under pressure, and all literally you're just smoothing and throwing on some trim lines. You're not doing a whole lot, and this workflow works a lot along that way.
Okay, good. Yeah, I'm glad. So we're now on the Advanced 3D website, and I've logged into the user portal, right? So This would be what you would see if you sign up. And if we go to the shape generator, this is the exciting automation we've been talking about this whole time.
So, and just for those watching and such, right now we're in the state, so we can speed up the processing side of things. We just haven't done that yet as we continue to kind of prove this thing out. So usually it's about 30 seconds or so before the initial socket pops up.
Okay.
And then we'll
hey.
So there it goes.
Awesome.
Okay. So so
what are we looking at?
Yeah, so this is your socket aligned on the Bulldog, which looks like it did everything correctly. If you scroll down on the left-hand side, you also see, so we have anterior, posterior. What's cool is if it comes in anterior, posterior, your lock body should be in the correct alignment. But if for whatever reason you just didn't bring it in the right alignment, you are able to flip that lock 180 degrees via that right under the voxel size. It says flip cut body. So these are specifically, well, they can be for FDM style printing. So, or you can go, if you wanted to do something for a powder bed fusion style print. And that's where it's like important, you know, you talk about resolution a lot, like high resolution versus low resolution. Well, the same thing happens here. So the lower the resolution, which is the voxel size, which you see the 0.5, the longer that it's going to take to compute the final socket. But for an FDM style socket, you don't need, especially in base mode, you don't need a lot of resolution. So I'll actually bump that voxel size up to 0.8.
Okay.
Yep. And then you make a decision if you go up on how thick you want your socket. So
5 millimeters start, hey? Is that a good one?
Yeah, so it starts at 5,
All right.
and we can expand that range. But I typically actually am in the 4, so I do 2 perimeters at 2 millimeters a piece.
Okay.
So then you have, we say, the inner and outer loft position. So down below, if you scroll down, you can take away some of the stuff that you see. So I'd leave the lock body on. You can turn the socket off. So essentially what we're looking at is how is that lock going to interact with the distal end.
Mm-hmm.
And so if you turn everything off other than that inner loft, you'll kind of get the hang of this, like where you don't, but now we're just, okay, so see how that loft, so it gives a nice flat surface and then it connects to the bottom of the socket. So if that doesn't look quite right, so put your the input mesh on, turn the input mesh on. All right. So, yeah. So that's how you get a nice clean look. So you see how it's kind of a hard edge at the back there.
Mm-hmm.
So what you would want to do is, that means that you want to move that loft a little bit up.
Okay.
So the inner loft, yeah. So let's move it up to, say, 45. And then just press compute and we'll see where it lands here. There we go. You see what that did? So it takes that loft and moves it up nice and flat.
Yeah.
Now, it's going to be interesting just because the way the distal end was rounded, what happens there. But I guess we're going to find out very soon. So actually, it's already generated the socket. So if you do single mesh, turn on the single mesh down below. Oh, maybe it didn't. Maybe it just generates whatever you've got on your preview. And so, we didn't run. So the key is the run dendro. That creates the solid body. So now we'll compute.
Ooh.
So there is the final socket. So let's look inside and see what it did. Oh, yeah. So it did the right thing. So it gave you your relief.
Mm-hmm.
And it made the socket the way it was supposed to.
Awesome.
So you can export that out if you scroll down on the left-hand side, and you'll get a better, and then open that up in Builder, and you'll get a better idea of what's going on. Did it download?
Is that the right? It is. There it is. All right. How do you sync?
Yeah, there you go. So you can see that when you go to a higher voxel, you're going to get to see some artifacts, but it's going to be fine for FDM. And then when you do just a higher voxel count, you're going to be a lot cleaner.
Okay, gotcha. Yeah. Yeah, the remeshing's got some, that's very interesting, the topology. I might remesh this just for fun, but...
yeah, do it. Let's just see it.
Okay, so... Nope. Something like that, just to help smooth it out. Polish. Flip. Oh. Yeah, I like all the rounded corners.
Yeah, so, but, how cool is it that you didn't have to do anything?
Yeah. This is my entire Fusion workflow for me.
Yeah.
So that's really cool. And so how do you see this being used in the future? Is this going to give access to quality design for people in developing countries or people who are worse off or just don't have access to that kind of experience? They want to subscribe to your method, how should they think about it when they want to use this or leverage this?
Yeah, well, this one is just a way to start, right? I think one of the things that is super important is with any of these programs is you want to put the clinical decisions into the clinician's hands. And I would say most of the clinicians couldn't care less how the socket was made and designed, and they don't actually want to know. They want to put in the modifications, and then they want the socket to pop out, right?
Mhm.
And so I think that's where I think this comes into play, is it gives them all the control, all the clinical control, like via Nomad Sculpt. They do all the things that they need to do, and then all they have to do is put it into this web app, and out comes a socket ready to print for their FDM test sockets. And so I think it just like when I think back of all the things that I've done, this just gives access right away to something that is, that is going to be a sound design. Now it's up to you. Your mileage may vary based on what printer you use and all that stuff. But as far as the way to design for FDM, this is a great, very strong way to do it. In fact, I've got one right here.
Oh, cool.
So, and it's just with not a lot of experience, right?
Yeah.
You're just dropping it in. So I believe, and I think that's one of the things that I think is super important for the O&P specific modification software, is they don't let you get to the spot where you can get a socket or a mesh out with trim lines. And I think that's a big mistake, because there are things, not the O&P software can only do so many things, and there's clinicians that may want to do some other things. And so like just recently I had a clinician, they could not get the mesh out, so they just modified a socket in a well-known program, O&P, and they sent me the socket. I grabbed the interface and I finished the device. But it was just, it's like, I don't understand why more people or more companies won't give the clinicians that ability to get their mesh out and choose how they design the device.
Well, I think the economics of, process-based software versus industry-based software plays a big role. If we can find a process-specific software, kind of like what Nomad Sculpt is, that's a mesh editing tool that everyone from any industry can use, versus an O&P specific software, which there's less than 10,000 professionals in all of the U.S., so the cost is just way higher, and the support and the building of it, the economics of it are way different. Being able to leverage one over the other is really going to see the dividends on that. And I think this is a cool blend of both, because you've got an automation from industry that's sort of tied into sort of a very process-based agnostic flow that gives people very affordable access very quickly.
Yeah.
So it's like a really cool blend, and I'm really excited for this. So people can sign up on your website, right? And you guys would approve them, and then they can try out for themselves, creating designs, ideally to be printed through you, I imagine.
No, so we want them to be FDM printing their own stuff. So, I mean, we could print their test sockets, but we truly believe in putting the power in the clinician's hands. And then when it's time to go to a definitive socket, hopefully you think of us, and we'll 3D print your definitive socket after it's been fit. But this is really a tool for the masses to be able to get a transtibial socket very quickly.
That's super cool. Well, hey, so in response to that, then I've come up with the video series for Nomad Sculpt, and there's a full course for including AFOs and some, residual limb, sound side limb, cosmesis, workflows, and SMOs. But the socket side of the videos I've just separated out for you and for people who want to take advantage of this. So for $30, you can actually just buy this whole tutorial for a start to finish guided walkthrough on how to modify this exact scan that we went through today. And hopefully you're going to be able to use this and recommend people to use it. And I'm certainly going to push people to try out your designs if Fusion 360 is not their thing. But again, just democratized tools. I think this is an amazing opportunity to sort of share that knowledge and give people the tools they need.
Yeah, well, and I love having all the options, right? So if you're a Fusion person and that's what you want to do, then that's perfect. If you're a freeform person, if you're whatever software, then yeah, go do it. But if you're not interested in any of that, that's where I think the web app stuff comes in. Or say you've been using the Fusion 360 and there is, it produces beautiful sockets, but it is time consuming and you got to do it every single time.
Mm-hmm.
The ultimate goal with this one, and it's not a heavy lift for us on our side, is if somebody's doing this in a large scale application, so say think of like small regional companies or even large companies where their technicians or clinicians can be modifying in alignment. They literally have 20 sockets modified in alignment. They can dump it into the tool and then out pops 20 sockets ready to print.
Yeah.
So that's the goal of that, to where you're not touching every single one.
Cool. Awesome. Well, hey, thank you so much otherwise for sharing this. This is going to be really interesting. I hope people get a chance to respond and sign up after this.
Awesome. Yeah, thank you. Thank you for pushing the boundaries of some of this stuff and really creating awareness around some of these tools that allow clinicians to be clinicians and also watch their bottom line. I think that's as important as anything else.
Yeah, you're absolutely right. That was the biggest upset for me, was the pricing when I got into the field. I'm like, wait a minute, we can't do this. Well, thank you so much. This has been really cool. I've really enjoyed this.
Awesome, man.